Usually when we look at a piece of modern gym equipment, there's this expectation of invincibility.
Oh, totally.
Like it's this massive, heavy construction of steel and sleek black plastic. You step onto a treadmill, you hit quick start, the screen lights up, the belt moves, and you just assume everything underneath is working in this perfect, indestructible harmony.
Yeah, we really prefer to believe that because a machine is designed for, heavy physical exertion, it somehow exists outside the basic laws of physics. It
Right.
feels solid, so we assume it's permanent. But looking at the field notes from the technicians who actually keep these machines alive, it completely shatters that
It
illusion.
really does.
We are looking at a mechanical landscape that is incredibly fragile.
Yeah, and that's exactly what our mission is today. We're going to uncover the hidden mechanics and, honestly, the economics of fitness equipment maintenance.
Hmm.
And we're drawing on this massive stack of field guides, diagnostic breakdowns, and service blogs from Heartbeat Fitness Repair.
Right, the team down in Florida.
Exactly. They are an on-site equipment repair company serving the Tampa Bay area, and they've completed over 5,000 repairs.
Wow.
Yeah. So we're going to break down the invisible chain reaction that causes catastrophic motor failure. We'll explore the 5 most expensive repair traps that owners fall into. And then we're going to give you a simple framework to basically double the lifespan of your gym equipment while saving, thousands of dollars.
It really is thousands. And to understand how these machines actually die, we have to start at the foundational mechanical level
Okay.
because it is almost never a sudden, catastrophic snap out of nowhere. It's a slow, agonizing death by friction and heat.
Okay, let's unpack this. Because the sources go into intense detail about this specific chain reaction. And it starts with a scenario. Most people, well, they would never even consider it, a dry walking belt.
Yeah, the dry belt. Every single time your foot strikes that treadmill belt and pushes it backward, the belt is dragging across the stationary phenolic deck underneath it.
Wait, phenolic, what does that mean exactly?
Oh, it's basically a very hard, durable composite wood.
Okay, got it.
So when the machine is new or properly maintained, there is this micro layer of silicone lubricant separating the belt and the deck. It glides.
Right.
But as that silicone desiccates over time, the friction coefficient spikes.
Oh, I see.
The belt is no longer gliding. It is physically dragging against the deck with the full weight of your body pressing down on it.
So just the act of running is actively fighting the machine's intended motion.
Exactly. And that resistance doesn't just, stay isolated to the deck.
It moves up the chain.
It does. The mechanical drag transfers directly up the drive belt and right into the main drive motor. So the motor is suddenly being forced to work significantly beyond its intended load capacity just to maintain a simple jogging speed.
But the motor can't just, pull more power out of thin air, though.
Yeah.
It has to demand that power from somewhere, right?
It demands it from the motor controller board.
The brain.
Right, the electronic brain of the treadmill. So as the motor struggles against the physical friction of that dry deck, the controller board has to pump higher and higher amperage into the system to keep the belt moving.
And pushing excess electrical current through sensitive circuitry has a very predictable outcome. It generates massive amounts of heat.
And heat is the ultimate enemy of all sensitive electronics.
Oh, yeah.
Semiconductors, capacitors, microprocessors, they all have very strict thermal limits. When you exceed those limits, the components begin to literally bake.
And to make matters worse, we have to look the environment inside the motor compartment itself. Because the sources describe these compartments as acting like industrial vacuums.
They really are.
They suck in airborne dust, carpet fibers from your living room, pet hair, and even get this tiny microscopic rubber particles that shave off the walking belt as it wears down.
Which is just wild to think about. That combination of debris creates a literal mat. It gets sucked into the intake vents, wraps around the internal cooling fans, and forms a dense insulating layer right over the heat sinks of that hardworking, already overheating motor controller board.
So the airflow is just completely choked off.
Completely.
So what does this all mean? It's basically like trying to drive your car down the highway with the parking brake engaged while someone has stuffed a thick wool blanket into your radiator.
That's a perfect analogy.
The engine isn't just working harder, it's suffocating.
Yeah, and from an electronic engineering perspective, thermal runaway is inevitable at that point.
Right.
The trapped heat bakes the components. Severe current spikes occur as the system tries to fight the mechanical drag, and eventually the controller board just fries.
And it takes the motor with it.
Often, yes. It takes the overworked drive motor right along with it.
Total system failure. over like a lack of a few drops of silicone lubricant and a quick vacuuming.
Exactly.
But the machine does try to warn the user before it completely gives up, doesn't it?
It does. You will often feel a very slight hesitation, like a tiny catching feeling when your foot strikes the belt, even at low speeds.
Like a micro stutter.
Yes, exactly. Or you might notice a very faint smell of burning rubber or hot dust. That is the drive system actively struggling to compensate for the excess mechanical resistance.
Okay, so now that we understand friction and heat are the executioners here, we need to look at the human behaviors that actually invite them in.
Right, the mistakes.
The sources detail 5 incredibly expensive traps people fall into, and it starts with mistake number 1, which is just the psychology of deferred maintenance.
What's fascinating here is that people often operate under the illusion that reactive maintenance saves money.
Right.
They notice a slight squeak or realize they haven't lubricated the belt in 2 years, but because the machine still turns on, they just defer the task.
They think, well, it's running fine today.
Exactly. They avoid spending a small amount of money or time today, assuming they are financially ahead.
The math on that decision is staggering, though. The sources point out that ignoring a $20 routine lubrication requirement creates this compounding disaster.
It really is.
Over 18 months, that friction builds, the amperage draw steadily climbs, the electronics bake under a blanket of dust, and then one day the machine simply dies mid-workout.
Just shuts down.
Yeah, and instead of a $20 tube of lubricant, you are suddenly looking at replacing the drive motor, the controller board, the deck, and the belt. A neglected 15-minute maintenance task has morphed into a $500 to $1,500 total system rebuild.
We are looking at a classic false economy, and it highlights 2 distinct types of neglect, which brings us to mistake number 2.
Okay.
Skipping lubrication and letting dust accumulate. Neglecting the physical lubrication kills mechanical moving parts, but neglecting to vacuum the motor compartment is what assassinates the electronics.
The hidden killer.
Right. A motor controller board alone costs $400 to $600 to replace, purely because lint and pet hair acted as a thermal insulator.
Okay, so if the first 2 major pitfalls are about doing too little, like not lubricating, not dusting, the next major trap absolutely blew my mind. Mistake number 3 is using the wrong cleaning products.
Oh, the overcorrection.
Yes. Wait, so being aggressively clean is actually accelerating its destruction. It's like using steel wool to wash your face.
It really is. The chemical warfare approach to gym maintenance is devastating.
I mean, it makes sense. You finish a sweaty run, you want to clean it.
Of course. Users naturally want to sanitize the equipment post-workout, so they reach for heavy-duty commercial products.
Bleach wipe.
Bleach wipes, ammonia-based sprays, or these highly concentrated disinfectants. They take these corrosive, moisture-heavy products and just scrub down the entire console.
But just because a product is sitting in the commercial cleaning closet doesn't mean it should go anywhere near a sensitive circuit board or like a capacitive touchscreen.
Exactly. Those harsh chemicals immediately strip the protective UV coatings off the plastics, and they begin aggressively corroding the external metal hardware. But the real damage happens when the liquid inevitably seeps into the microscopic seams around the physical buttons and the edges of the display screens.
Oh, because it doesn't just evaporate.
Right. And it's not just the cleaner seeping in either, it's mixing with everything else on the console.
Which means sweat.
Human sweat is already highly acidic. When you combine acidic sweat with a caustic cleaner like bleach or ammonia, you create a highly concentrated chemical slurry.
A slurry, wow.
Yeah, and that liquid sits directly on top of the delicate copper traces of the circuit boards that run the entire machine. It causes rapid galvanic corrosion, eating through the electronics in record time.
That's terrifying. And a console replacement is often the single most expensive repair on a modern machine, easily running $600 to $1,500.
Just for a screen.
All because someone grabbed the wrong spray bottle.
Yeah.
The sources are very clear on the alternative, though. You use a slightly damp microfiber cloth, maybe a manufacturer-approved, non-corrosive electronics cleaner. You wipe the sweat off gently. You never spray liquid directly onto the machine.
You really have to treat the console of a treadmill with the same caution you would use when cleaning a laptop keyboard.
Right. Nobody sprays Windex directly into their MacBook.
Exactly.
Okay, so we have the dangers of neglect and the dangers of chemical overcorrection. Let's shift to the traps born out of active mismanagement. When people actually see a problem but make the wrong call.
Right.
This brings us to mistake number 4. The danger of ignoring physical warning signs, particularly on strength equipment.
This is a big one. Moving from cardio to strength machines shifts the conversation from purely financial risk to severe physical liability.
Stakes are higher.
Much higher.
Yeah.
A frayed cable on a functional trainer or a multi-station weight stack is not just a casual maintenance note on a clipboard. It is a ticking clock.
A very loud ticking clock. I mean, if you see a fray, the internal steel strands of that cable are actively failing.
Yes. And if that cable snaps while a user is mid-set under a heavy load, the sudden violent release of kinetic energy is catastrophic.
I can't even imagine.
The weight stack crashes down, often shattering the pulley systems and physically warping the steel frame of the machine itself. But more importantly, the user loses all mechanical resistance instantly, leading to torn muscles, joint dislocations, and massive medical liability claims.
All from a frayed cable. But a weekly walkthrough, just putting your hands on the cables, visually inspecting the nylon coating, listening for an unusual squeak in the pulleys that catches these distress signals when they are cheap and easy to fix.
Exactly.
Replacing a slightly frayed cable is an inexpensive repair. Defending a structural failure or a medical injury lawsuit is definitely not.
No, it's not. Equipment maintenance at that level is fundamentally about risk mitigation.
Right.
It's about identifying the anomaly before it becomes a hazard.
Which leads us to the final and perhaps most tempting trap for anyone trying to save money. Mistake number 5. DIY fixes and cheap aftermarket parts.
Oh boy.
Now, I have to play devil's advocate for a second here.
Go for it.
Parts are incredibly cheap online right now. You can go on an e-commerce site and find a replacement belt or a motor control board for a fraction of the official manufacturer's price.
You can.
Why shouldn't a gym owner or, a handy homeowner who knows their way around a toolbox just pull up a video tutorial and swap a part themselves?
It is an incredibly tempting shortcut when a machine is out of order. I get it. But here's where it gets really interesting. Modern fitness equipment relies on highly calibrated motor control electronics and extremely strict mechanical tolerances.
Okay.
Counterfeit aftermarket parts rarely meet those original equipment specifications, and trying to save a buck could literally void the warranty on a $4,000 piece of equipment.
But how does that actually play out inside the machine, though? Let's say I go online, I buy a cheap off-brand motor controller board, and I install it.
Well, an aftermarket board usually lacks the robust thermal sinks and high-quality capacitors found on the original. So it cannot handle the heat we discussed earlier. It fails significantly faster. Furthermore, when an inferior component fails, it often sends erratic, uncontrolled voltage downstream through the wiring harness.
Oh, no.
Yeah, instantly destroying other original expensive components along the way.
So you think you're saving $100 on a circuit board, but you end up frying the entire system.
Exactly.
And when you finally swallow your pride and call the manufacturer for help, they pull the service logs, see the unauthorized part, and void the entire warranty.
It happens all the time. A DIY fix also suffers from a lack of proper diagnostic protocol.
What do you mean?
Well, a handy homeowner might successfully swap out a burnt drive motor, right? They treat the symptom. But without professional multimeters and amp draw tools, they won't realize the disease is a worn-out phenolic deck creating massive friction.
Oh, so the deck is still bad.
Yes. So the brand new self-installed motor is just going to burn out again in a few months because the root cause was never actually diagnosed or resolved.
That makes total sense. Professional technicians don't just swap parts. They diagnose the entire interconnected ecosystem of the machine.
Exactly.
Okay, so if human error, friction, and a lack of diagnostic tools are causing all this catastrophic damage, how do we actually interrupt that chain reaction before it starts?
We need a system.
Yeah, what is the practical framework to protect the investment?
The sources outline a really proactive routine that fundamentally alters the life cycle economics of the equipment, and we can break it down into daily, weekly, and quarterly habits.
Okay, lay it on me.
Well, the daily routine takes literally 5 minutes.
It's 5 minutes. Anyone can do that.
Right. After every use, grab that slightly damp, soft cloth, remember, no harsh chemicals, and wipe down the acidic sweat.
Easy.
Then, do a quick belt tension check. Just lift the center of the treadmill belt. It should have about 2 to 3 inches of give.
So that removes the chemical threat to the console and provides an immediate baseline reading on the mechanical tension of the belt.
Exactly.
Okay, what about weekly?
Moving to the weekly routine, it's a quick electrical and mechanical sweep. Look for frayed power cords. Check the cables on the strength machines for any exposed steel strands like we talked about.
Right, catching the frayed cable before it snaps.
Yes. And just ensure the hardware feels stable. Then the quarterly routine is where we directly combat the friction and heat.
The big guns.
Unplug the machine, remove the motor cover, and carefully vacuum out the dust accumulation from the cooling fans and the circuit boards.
And what about the lubricant?
Yes. Every 150 to 200 miles, or roughly every 3 months, apply a lubricant under the belt. But the sources are incredibly strict about this.
Never, ever use WD-40.
Never.
I feel like everyone just grabs the blue and yellow can for everything that squeaks.
Oh, totally, but that's the worst thing you can do. WD-40 is a water displacement formula and a solvent. It is primarily composed of petroleum distillates.
So it's not a lubricant.
It is not a friction-reducing lubricant designed for treadmill belts. If you spray a solvent onto a synthetic rubber belt, it will chemically break down the adhesives holding the layers of the belt together,
Just melting it.
completely destroying it. You must use a 100% silicone-based treadmill lubricant. The silicone actually permeates the backing of the belt and interacts with the phenolic deck to maintain that critical glide layer.
Okay, so daily wipe down, weekly visual check, quarterly vacuum, and silicone lube. But the physical environment of the machine is just as crucial as the routine, right?
Oh, absolutely.
Yeah.
Placing a treadmill in a damp, unconditioned basement introduces high humidity, which causes internal rust and electrical shorts.
What about sunlight?
Placing it directly in front of a window exposes the plastics in the belt to intense UV sunlight, causing the materials to become brittle and crack.
The sources mentioned a mat, too.
Yes. One of the most effective preventative measures is spending $50 on a high-quality, dense equipment mat to place under the machine.
Just a piece of rubber on the floor makes that much of a difference.
Huge difference. It acts as a physical barrier. It prevents carpet fibers and floor dust from being sucked up into the motor compartment's vacuum effect.
Oh, keeping the dust out in the first place.
Right. And it also dampens the mechanical vibration, which protects the sensitive solder joints on the internal circuit boards from shaking loose over time.
That is brilliant. Okay, and that brings us to the actual bottom line economics, where this whole framework proves its value.
Let's talk numbers.
Because a quality home treadmill costs anywhere from $2,000 to $4,000.
Be silly.
If you do no maintenance, if you just run on it until the friction and heat completely destroy the drive system, it will last roughly 5 to 6 years.
Yep.
That means you are paying $400 to $650 for every single year of use.
Which is a steep depreciation curve for any consumer appliance.
Very steep. But if you follow this simple framework, that exact same machine lasts 10 to 12 years. You literally double its lifespan.
It's amazing.
Your cost plummets to $200 to $350 per year of use. If you look at the math, you're cutting the annual cost of owning a treadmill in half just by spending 30 minutes a month cleaning it and getting a pro to look at it once a year.
And if we connect this to the bigger picture, that professional visit takes the complex diagnostic guesswork out of the equation. Heartbeat Fitness Repair notes their service call fee in the Tampa Bay area is roughly $150.
So you pay $150 for a factory-trained technician with the proper diagnostic tools to open the machine.
Right?
They check the amp draw of the motor, verify the electrical grounding, align the belt tracking, and just optimize the system.
Exactly. That $150 diagnostic visit actively prevents the $1,500 total system failure we talked about earlier.
So you handle the day-to-day cleanliness, and the technician handles the mechanical and electrical calibration.
It shifts equipment maintenance from a reactive chore into a calculated investment strategy. It's so true. Keeping your fitness equipment alive and running smoothly is fundamentally about managing invisible forces. It's about managing the microscopic friction under the belt. It's about venting the trapped heat inside the motor compartment.
Yep.
It's understanding the chemical reactions happening on your electronics. And above all, it's about paying attention when the machine signals that it's struggling.
It demands an approach where we respect the intricate mechanics of the machine, rather than just blindly exploiting its utility until it breaks.
It's a complete paradigm shift in how we view the heavy steel and plastic in our gyms.
It really is.
And that leaves a final thought for you to mull over. We've spent this entire deep dive analyzing the devastating compounding effects of invisible friction and trapped heat inside a single treadmill.
The slow death.
Exactly. How a tiny lack of silicone or a layer of dust can cascade into a catastrophic system failure. But take a look around your house right now.
Oh, this is a good point. What other expensive motorized appliances, your HVAC system, your washing machine, or your garage door, are slowly burning themselves out at this very moment just because they are missing a $20 drop of lubrication or a 5-minute vacuuming?